Hi everyone, so today we're going to look at lesson 3 and looking at two-way tables and how we can use them to calculate probability. Now a two-way table is just a table that summarizes data and showing the relationship between two variables. So if we look at example 1, we have pizza toppings and gender, so between females and males. So Mr. Evans surveys his students on what their favorite pizza topping is, and we want to use this table to answer the following questions. So what percent of participants are male? So we want to look at the total participants, which is 109. And then we want to look at how many are male. So out of 109, we have 50 that are male. So if I divide those two, I would get a percent of 45.8%. Now, if I want to find the probability of selecting a student whose favorite pizza topping is pepperoni, again, I want to look at a student, and we have a total of 109 of them. And then we want to find out from those students how many have pepperoni being their favorite. So we have pepperoni, we have a total of 57. So we have 57 out of 109. And then you can also give the percent, which is 52.3%. Now the percentages that we calculated here, these are called marginal relative frequencies. And all that is, it's just giving the percent or proportion of one subgroup, and I'm comparing it to the total number of individuals that I would have. So you might have in a table to calculate the entire row, or you might have to calculate the entire column, and then you're dividing it by the overall total. Now, a joint relative frequency is giving the percent or proportion of individuals that meet two separate categories. So that might depend on what the question is asking you, so we'll have to just read your question carefully. Now, if we look at the table for example 2, this is the same table that we just looked at. We've got our table here. So if we use that same table, just kind of copy and paste it. We want to know what percent of participants. So again, we're looking at the total number, 109. We want to know how many are male and happen to prefer sausage. So how many are male and happen to prefer sausage? So I have 11. So again, if I divide, I would get 10.1%. Now we want to know what percent of participants, so again, was the total participants. We want to know how many are female and prefer cheese. So how many are female, how many prefer cheese? That is 26. So if I divide 26 by 109, I have 23.9%. Okay, now we're going to look at conditional relative frequency, and this is just giving us the percent or proportion of individuals that meet a certain condition within a subgroup. So it's important to know that we're just isolating either one row or one column and working within that row or column. So again, if I copy and paste that table from above here, we're going to look at, again, these 3 questions based on that table. So I have what percent of male students prefer sausage pizza? So now I'm not looking at total participants, I'm looking at male students only. So I'm going to be focused on my male column. So I have 50 males, and I want to know how many prefer sausage. So I'm going to have 11. So if I divide, I would get 22%. Okay, now we want to look at what percent of those who prefer sausage are male. So I'm going to look at how many of those who prefer sausage. So how many of those who prefer sausage? So I have 15 who prefer sausage. And then I want to know how many of them are male. So again, I would have 11, which would be 73%. And question C, we want to know what percent of those who prefer cheese pizza. So what percent of those who prefer cheese pizza, that's 37. We want to know how many of those are female. So how many of those are female? That's 26. So again, if I divide, I would get 70%. Okay, so we're going to leave you this you try question. Okay, some of these symbols are from yesterday's lesson in lesson 2. So you have conditional probability. You do have ones that you might have to look and read carefully about. It says not. You have a keyword that says or. You have and. So be careful and look back at lesson 2 in order to do question number 4. And we're going to look at independent events here on page 3. Now, independent events is pretty much just saying that the outcome of the first event that happens has no impact on the outcome of the second event. Okay, so given B doesn't matter. So B doesn't really matter. I'm just pretty much looking at the probability of A. So let's look at this two-way table that you have in example 5. So now we have a table that describes the adult passengers on the Titanic and those who survived, as well as those who died, as well as their class of travel. So let's look at those questions together. What's the probability that a passenger survived? All right, so we want to know how many of the passengers we have in total. So out of the total of 1,207 passengers, we would like to know how many survived. So we're looking at the survived row, which is 442. Okay, again, you can give a percent or you can leave it as a fraction. In letter B, we are asked, what is the probability that a passenger survived given that they were in third class? So there's your word, given that they were in third class. So the third class is your A event, and the passenger survived is your third class is your B event, and then the passenger surviving is your A event. So remember, this is your conditional probability. So what we have to do is we have to find the probability of A and B happening and divide it by the probability of B. So what is the probability that a passenger survived and that they were in first class? They survived and in third class, that was 151. Then we are going to divide it by the probability of B being third class, which is 627. So in question C, we want to know what's the probability a passenger survived given they were a first or second class passenger. So let's look at first class, and then we want to look at second class. So we want to find, again, the probability. This is conditional because you have that given word. That's your keyword. You want to find the probability of A and B happening and divide it by the probability of B. All right, so we want to find, first of all, we do have an or. So let's find the intersection. So what's the probability that a passenger survived and was in first class? That is 197. And we also have an or, so we'll have to add that probability. And then you have the probability of the intersection of survived and second class, which is 94. Okay, and then we're going to divide it by the probability of B. So we want to find how many were first class passengers, which was 319. And we're going to add it to how many were second class passengers, which is 261. All right, now if I add these together, I get 291 over 580. So you do have a conditional probability within having to find the probability of the or if they're mutually exclusive. All right, so we're going to leave you question 6 to try. So once you try number 4 and number 6, go ahead and submit your notes into the lesson 3 video notes assignment.